Good morning and good afternoon, everyone. On behalf of Deakin University and KPMG, I welcome you all to this great session on the coming war for AI talent. As artificial intelligence increases in importance in new technology and applications, several people have risen to the top of the field, achieving expert level status and providing insight into breakthroughs, new applications, and ideas about the technology. Organizations across sectors are in the midst of an artificial intelligence boom as we know it. According to a recent report from Transparency Market Research, the global AI market, valued at $126 billion in 2025, is set to grow more than 36% annually from 2016 to 2024 to top 3061 billion in 2024. Now that is an amazing growth. The adoption of artificial intelligence and deep learning to harness their transformative potential is becoming a key priority for most organizations. This has given rise to significant demand for artificial intelligence and deep learning skills in various industries, including healthcare, e-commerce, finance, retail. The possibilities are absolutely have come together to launch a program on artificial intelligence for working professionals, which will be introduced to the market shortly. Today's session, my dear friends, with Deakin University and KPMG in India is jointly hosted as a panel discussion on deep learning and artificial intelligence and the future of work. This virtual session aims to provide insight in the following three areas: the impact of AI on organizations and rate of adoption, demand and supply gap of AI professionals, what kind of skills is the industry looking for in AI professionals in today's world and age, business leaders, senior executives, professionals of data science and IT professionals. We are happy to talk to you about these very interesting areas. I've got a great panel with me today, but let me start by introducing our keynote speaker, Mr. S. Ramadurai. Mr. S. Ramadurai was in public service from February 2011 to October 2016. During his tenure as the chairman of the National Skills Development Agency and the Skills Development Corporation, his approach was to standardize the skilling effort in this country. Mr. Ramadurai then started with TCS and has been the CEO of Tata Consulting Services since 1996, when the company's revenues were at $155 billion. And since then led the company through some of its most exciting phases, including its going public in 2004. In October 29, he retired as a CEO, leaving a $6 billion global IT service company to his successor. He was then appointed as a vice chairman and retired in October 2014 as an association of over 4 decades with the company. Mr. Ramadurai is currently the chairman of the advisory board of Tata Strive, which is the Tata Group CSR skills initiative and aims to address the pressing national needs for skilling youth for employment, entrepreneurship, and community enterprise. Over to you, Mr. Ramadurai. We're going to play his video because he's unable to be with us in person, but we are going to play his video that he has recorded for this session. David?
Good morning to everyone. Ravneet Pava, Deputy Vice President, Global CEO, South Asia for the Deakin University. Other senior representatives from Deakin University and KPMG India. Ladies and gentlemen, a very good morning to all of you. I'm extremely happy to be a part of this virtual session, Coming War for the AI Talent, when the demand for artificial intelligence and deep learning skills are growing significantly across all industries, across all sectors around the world. As you may be aware, the world has already entered an exciting and unprecedented phase in technology, with the pace of change and innovation which continues to accelerate. And this has been also fueled by the onslaught of COVID. A series of global megatrends, such as rapid urbanization, demographic shifts, changes in global economic power, political shifts and technology are influencing the way the various businesses are being run. I think the so-called fourth industrial revolution, Industry 4.0, holds tremendous opportunities for the future of our country, particularly because of our demographic profile and the advantage which we have. I think the combination of nation's demographic dividend and data with proven tech prowess presents immense possibilities for India. With the right attitude, infrastructure, and policies, India can certainly build the largest pool of technologically proficient human capital anywhere in the world. As stated by the well-known Amara's law, we tend to overestimate the effect of a technology in the short run and definitely underestimate the effect in the long run. When I look at artificial intelligence, it's more or less the same. We may not be able to predict the accurate extent, but I'm sure artificial intelligence will change the future. We can already see and witness the tremendous power and unprecedented transformations being enabled by artificial intelligence in every sector. We have seen disruptive new business models which have emerged. This is purely based on technology, asset light, or not owning any assets, but then posing a serious challenge to the long established incumbents. This is the kind of disruption we need to look for and watch out from anywhere, any place, any part of the world. These fully virtual entities have used digital technologies to set very high standards in terms of, one, customer experience, and fundamentally changed the equation between business and technology. Today, when you look at it, digital technologies are defining businesses across industries and is a key driver of competitiveness and also business viability. Transformation led by AI and other digital technologies over the past few years has only been accelerated by the pandemic, even though it is unfortunate. Many organizations have had to update demand patterns, reconsider completely supply chains, build scenario planning around resource needs, and enable automation in factories and other industry settings where the workers need to distance and very few people are at the exact location. Remote management, remote production, and remote collaboration, and remote co-creation through virtual spaces have become a way of life, which is called phygital, essentially intelligence embedded within the physical workspaces, voice-controlled apps, digital whiteboards. The Internet of Things-based asset tracking and securing workplaces remotely and so on is being witnessed. As we adapt to this digital shift and try to leverage the enormous amount of data that is being generated in a digital environment, AI and automation will provide a much needed boost to productivity and may help tackle some of the critical challenges that the world faces today. AI today has become an area of strategic importance, potential to be a key driver of economic development. AI has also a wide range of potential social implications. The point I'm trying to communicate is looking at AI only from a technology lens will be essentially a myopic approach. The need is to have a mindset change to look at AI as essentially a new way of doing everything. Also, AI is a journey and continuum, and not a snapshot at any point in time. Solutions would evolve, and so would be the acceleration in technology capabilities. We are moving towards a future of omnipresent connectivity, from connected cars to smart appliances to connected energy meters to connected homes, connected wearables, and connected healthcare, which means essentially a connected life. With the rapid increase in the connected devices over the years, which is expected to reach 1 trillion by 2025, AI-enabled automation will certainly play a decisive role in improving the quality of life and productivity through its unmatchable ability to process enormous amounts of data to derive desired outcomes. Object recognition in billions of images in a few seconds, instantaneous translation of 100 plus languages, and identification of spam from billions of emails, weather prediction in record time, disease prediction, prediction of traffic congestions, chatbots and virtual assistants, and so on are some of the examples by which AI will transform the way we interact with our environment and make sensible, far-reaching decisions. Predictive analytics using AI will help us to optimize deployment of resources, maximize productivity, and achieve timely and more effective decision making. AI-driven automation is already taking over routine, repetitive tasks in many industries and is being deployed for complex and specialized tasks such as radiology and pathology in the healthcare space. Again, looking at the healthcare sector, diagnostics and imaging technologies are generating an enormous amount of data. Doctors and software engineers have moved to computer-aided diagnostic tools to guide the interpretation of data. The healthcare industry has now reached a point where the data sets are large enough, machine learning is sophisticated enough, and the amount of investments being made on research is huge enough that it is increasingly evident healthcare will certainly be one of the key industries that will be disrupted by artificial intelligence. For an industry which has a lopsided doctor-patient ratio or a specialist availability, this phenomenon is likely to accelerate. Tasks such as mundane monitoring of vital signs in ICUs to reading diagnostic images and performing the most complex surgery will be increasingly carried out by learning machines and robots. AI is making a major impact in all domains of the industry, as I said. Every industry looking to automate certain jobs through the use of intelligent machinery, including agriculture. Farms will be even more mechanized and automated. We will see robot tractors, robot harvesters, and drones and satellites to monitor how a crop is doing. AI has emerged as a tool that empowers farmers in monitoring, forecasting, as well as optimizing the crop growth. Precision agriculture, as it is called, again uses AI in several areas. AI-powered advisory tools help to keep track and predict the right time for planting, irrigation, harvesting, which has also been deployed in India. The consequences will be higher yield and higher income for the farmers and will help the planet of 10 billion feed itself, as the world population is expected to reach 9.7 billion by 2050. However, the transformative power of AI and the risk it carries are forcing enterprises to reassess their approach on cybersecurity and data privacy. While enterprises are using AI to automate multiple tasks, reduce human errors, and correlate huge security data sets to derive significant insight, on the flip side, enterprises are increasingly being targeted by rogue actors who are using AI to launch stealthy polymorphic attacks that are essentially increasing in sophistication. Beyond adherence to local regulations and meeting consumer expectation as part of their AI products, enterprises must ultimately balance business interests with social considerations and absolutely establish ethical standards, especially around aspects that cannot be adequately regulated. Several AI deficiencies, including data quality and representativeness, can lead to biased, non-transparent, and low-performance AI. Malicious actors can use AI to make fake news, deepfakes, perform highly automated cyber attacks, etc. AI risks need to be addressed. Many ethical committees are working on AI fairness, accountability, transparency, explainability, and related issues, paving the ground for definitely governmental regulations. Border-related governance and policies also need to mature. As we understand and discuss implication and complexities of AI, we must realize that for any enterprise, talent development will be a key aspect of formulating an AI strategy. An overall AI transformation journey needs to start by identifying the right AI roles and calibrating AI talent acquisition with overall AI maturity. Since AI has a close dependency on in-depth understanding of functional domains and data, it's necessary to enable capability building and domain-specific functional AI expertise. According to the World Economic Forum's Future of Jobs report by 2020, by 2025, 85 million jobs may be displaced by machines, but 97 million new roles may emerge that are more adapted to the new division of labor, essentially between humans, machines, and algorithms. AI talent war is for real. Successive reports have shown that organizations that invest in building their own AI talent pool perform better in realizing value from their AI investments. To essentially win the talent war, there's a need for C-level commitment to AI, building a way enlarged talent and training ecosystem which spans academia, startups, partners, and formulating an effective AI talent strategy. And to formulate an AI talent strategy, AI adopters should look at how specialized their AI needs are, we can also consider involving business leader throughout the life cycle of AI initiatives. These leaders can connect the organization, business goals, and establish metrics to define success. Change management experts can also help to overcome AI integration hurdles. Within India, the National Strategy on AI, which was published in 2018, identified key sectors for AI-led development and growth and set the vision to make India AI garage for 40% of the world by leveraging its scale, huge talent pool. India ranks third worldwide in AI research and a vibrant IT services industry. For a broad demographic population like India, realizing the AI potential will mean large-scale reskilling, fostering entrepreneurship, focused engagement between industries, academia, and government, and clearly a policy framework. Collaboration of the highest order is the key to achieve acceleration at scale and the desired outcomes. With the new education policy, NEP, and the AI policy, India has laid a roadmap to harness the unique opportunity encouraging social development and inclusive growth. I'm happy to note that Deakin University and the KPMG India have launched a joint certification program in AI and deep learning targeted towards business leaders, senior executives, and professionals of data science and IT. I think this has come through at the most appropriate time, knowing fully the war for AI talent is for real. I would like to congratulate Deakin University and KPMG India on launching this course and wish the course every success. As the artificial intelligence becomes pervasive across all industries and business function, the demand will only be as much as we can produce, and absorption into the sectors of the economy will become for real. Business leaders who are trying to attract AI talent should collaborate more with universities like Deakin University and others, offering similar programs to develop and nurture the talent across the various sectors, which will address the supply versus demand. I think there is a lot of excitement around this technology. Imperative to have a holistic approach towards AI adoption, and this can be done through the development of AI capabilities and an enhanced knowledge base. I think we must all monitor the evolution, and when we look back after 5, 10, 15, 20 years, truly we become the global talent for AI and machine learning with applications which are real and which are productive in terms of impact. I think we are accelerating towards a digitally transformed society, and I wish the organizers the success and thank them for focusing on the most needed in India. Best wishes, and thank you so much.
Thank you, Mr. Ramdurai, for that lovely address. I think, adoption of artificial intelligence and deep learning to harness transformative business is an absolute imperative. And while there is huge demand for skills, which is projected to grow in the coming years, most organizations are facing a supply gap of AI professionals who have a strong foundation in this subject, particularly. The joint program with KPMG and Deakin aims to prepare experienced data science and IT professionals for a career in high growth field of artificial intelligence and deep learning. This program helps learners to develop an in-depth understanding of foundation concepts of business statistics, machine learning, artificial intelligence, and deep learning. This is a 400-hour program and will typically be spread across 6 months with live, highly interactive sessions, 2 days a week with assignments and industry interactions. The participants of this program will typically be a data scientist or an IT professional with 4 to 8 years of experience. They must have an undergraduate degree and a cognate degree in computer science, IT, or mathematics. There are 4 modules in this particular program: modern data science, mathematics for artificial intelligence, machine intelligence, and deep learning. Successful participants will receive a jointly badged certification from Deakin University and KPMG. They can use these 4 modules as credits to transfer into a master's degree at Deakin University onshore, and we call this recognition of prior learning. Thank you, colleagues, for listening to us patiently. I'm going to now introduce a very, very learned panel today that we have to talk about this very interesting area. The first on the panel is Professor Switha Venkatesh. She is an ARC Laureate Fellow, Alfred Deakin Professor, and a co-director of Applied Artificial Intelligence Institute at Deakin University. She was elected a Fellow of the International Association of Pattern Recognition in 2004 for contributions to formulation and extraction of semantics and multimedia data, a Fellow of the Australian Academy of Technological Sciences and Engineering, and a Fellow of the Australian Academy of Science for groundbreaking research and contributions that have had clear impact to lives we lead. In 2017, Professor Venkatesh was appointed an Australian Laureate Fellow, the highest individual award the Australian Research Council can bestow. Thank you, Switha, for being with us, and it's a pleasure to have you with us today. The next person on the panel is Mr. Ashok Mysore. He has over 30 years of experience in the industry across telecommunications, financial services, logistics, energy, utilities, services industries. Ashok, as Vice President and Regional Head for Australia and New Zealand in Infosys, is responsible for developing a performance-driven culture among a group of diverse and talented professionals to achieve accelerated profitable growth, the challenging markets by delivering value while continuously improving in internal efficiencies. Ashok joined Infosys in 2004 to lead the telecommunications business, and since has held numerous senior roles before taking up the regional COO role in 2014 to lead delivery and operations across Australia and New Zealand. Thank you, Ashok, for being with us here today, and it's an absolute pleasure to have you with us. The next person on the panel is Srijat Srivasan, is the Director of Business Excellence in KPMG. He leads the South region of Business Excellence practice at KPMG in India. In this portfolio, he manages transformation and advisory projects in Agile, data science, and Lean Sigma. His team works with some of the top technology and engineering organizations in India to transform their business operations and improve KPIs such as agility, customer satisfaction, productivity, cost optimization, quality, and on-time delivery. He has worked with clients across technology, financial services, and industrial engineering sectors. Thank you, Srijat, for being with us. And the moderator for this session, a dear friend, Mr. Vijay Gogi, is an associate partner and lead at KPMG Academy. His 22 years of experience has been largely in management consulting, sales, talent development, general management, and for the past 5 years as a technology entrepreneur. Vijay has extensive experience in hunting for saluting and selling talent development and learning consulting projects in India, US, and ASEAN, and has advised over 100 top Fortune blue chip clients on strategic talent and learning and development issues. Thank you, Vijay, for being with us. And I do want to, on this occasion, thank KPMG for partnering with Deakin University for bringing together a very unique program to uplift and upskill people in India. And then we hope to take it globally too. So over to you, Vijay, for this very interesting and exciting session for such a lead panelist.
Thank you. Can you hear me? Am I audible? Okay. Thank you, Ravneet. Thank you so much for the kind introductions, and thank you for inviting us and giving us this opportunity to speak on a subject that is very topical and very relevant for organizations, for businesses, as well as individuals. We have a very distinguished panel of speakers with a variety of experiences, and more importantly, from very different vantage points. I think it will lead to a very, I'm sure it will lead to a very good, rich discussion today. The context of this discussion actually has been very beautifully summarized and expressed by Mr. Ramodarai's keynote speech. He talked of the mega trends that is the world is seeing today, talked of Industry 4.0, the rise of AI, and the wide variety of applications of AI that we are seeing across, in our daily lives today. I just wanted to add a little bit of historical context about AI. The concept of AI has actually been there since the 1950s, mid of 1950s, and then it held out tremendous promise and potential since the early days. It saw a lot of funding and research, investments, etc. But however, by 80s or so, I think there was a kind of a dip in the interest in this in this technology simply because it did not fulfill the promise that it initially had. And this period from about 80s to about early 2000 is what we call an AI winter, where the interest in AI, artificial intelligence actually dipped. And just a personal anecdote over here. This is during that time that I did my final year engineering project, and that was on AI, on neural networks, and that too on a pattern recognition problem. And one of the things that we were trying to solve, I was trying to solve as a part of the project, is how do we tweak the algorithm in such a way that it actually reduces the demands it makes on the processing power of the computers at that time. And we were trying to do AI on a Pentium PC, and it used to take hours to get results, right? So that was essentially the problem, which is processing power and even lack of data. But over the subsequent years, you see the exponential rise in the processing power, the exponential rise in the data that is available, the data sets that is available, which is why now AI has come back into the limelight again, and it is actually kind of fulfilling the promise that it held out initially. And as Mr. Ramodarai noted in his speech, he gave a lot of examples in healthcare and agriculture. The whole concept of precision agriculture was very interesting. And you can actually see that AI is living up to its promise now. And the result is that a lot of organizations are adopting it. And when organizations are adopting it, it has resulted in the need for people with this AI skill sets, right? And that is where we don't have enough people with AI skill sets, and that is what is creating this whole war for AI talent, right? So so I'll kick off the discussion, and I'll actually first ask Ashok to give his introductory comments. Ashok, you lead pretty much a very large part of the Infosys business, and you're pretty much in the front lines in this war, right? So I just want to get your views on what are you seeing in the front line? What is driving this this demand for AI, this demand for AI skill sets, and what's the demand supply gap looking like? So over to you, Ashok.
Yeah, thanks so much, Vijay. And I think before I start, congratulations to Deakin and KPMG on this foray to upskill and build AI and deep learning talent. I mean, what better place to do this other than in India? So I guess as you introduced and as Mr. Ramdarai very eloquently put, where AI was. So even if we actually just think, 5-6 years back from say 2015, 2014, 15. The first driverless car was demonstrated by Google through the Waymo project, and it was not too many years back. I mean, this was only like 6-7 years back, though the Waymo project actually kind of started around 2010. And then you look at milestones each year after that, right? So 2016 was, when the world's greatest Go player, Lee Sedol, actually lost to AlphaGo. Then, DeepMind basically got AlphaGo 0, to actually, to play a machine versus machine, where the neural networks actually were, to superhuman levels. So we saw that in 2016. And AI just didn't actually stop in, just the technology part of it, right? So then when you actually look at the generative adversarial network, the GAN network, and in 2018, the first, I guess, painting was actually done by an AI engine, and which was actually sold at about, I think, USD $400,000 by Christie's in an auction. And that was based on the AI engine basically consuming about 15,000 portraits from the 14th century right through the 20th century. So we saw that. 2019 we saw Google Duplay, which carried out the realistic and natural conversations by imitating these things. 2020, right? I mean, today when we actually look at just a year back, the Mayflower project in UK, is basically a completely unmanned, crewless AI-controlled ship to cross the Atlantic Ocean. right? So that project, and actually in June, they did actually trial it. It ran for about 3 days, and then it had some engine problems. So it had to come back to the deck for the repairs. But where I'm going is, I mean, when we talk about demand, over the last 6 years, I think Ravneet pointed out to start with, there has been a jump of about 75% in just AI ML jobs in the last 2 to 3 years. And it is actually projected to go at a compounded annual growth rate of about 40 to 45% over the next 3 to 5 year period. So the demand is huge. And obviously, we heard a lot of examples from Mr. Ramdarai around autonomous vehicles, healthcare, etc. But then when you actually look at space exploration, for example, NASA's Mars rover, social media itself around face verification, using deep neural network for, and companies like Twitter, which basically stop messages coming out from terrorist organizations, and that was about 300 million stuff. So I mean, we can actually see the industry needing a huge amount and a huge quantity of skilled resources around AI and machine learning and deep learning, because the applications of that is so broad. So we can actually discuss a little bit more about it, as we go through this. But I think that's a reason why we see, I think, the demand for AI being so prevalent today.
Thank you, Ashok. I think this is, it's very interesting to note the rate at which the demand is growing. 40-45% CAGR is like phenomenal, right? I'll turn to Professor Venkatesh, I just want, you are in academia, and you are in the business of creating the talent that everyone is fighting for, right? And so just tell us about, from your perspective, what is this AI skill set, right? What is it that they are, that organizations really want when you talk about an AI professional?
Yeah, I think this is a really interesting question with a very deep answer. It's not a quick answer. So it's my own, with my own experience in training people in AI and machine learning and pattern recognition over several decades now. AI is not like programming. It's not like learning Python or PyTorch or knowing how to do something and then you just do it and then everything happens magically. I mean, something will happen, but it may not be the right thing that happens. So I think that the very important thing in the skill set here, and this is something I'm grappling with myself because everyone has the same problem, is it's not just important for them to know the mechanics of what to do. So there is the mechanic side of the skills that is required. What is machine learning? How do you do deep learning? How do you build networks? How do you train networks? But there's also a part of the skill which is deeper, right? Like what happens when the training data is different? What happens when the distribution of the training data is so different? You may take this off-the-shelf model from Google and you might use it with the data from, say, India, and it's never looked at data like this before. And then how do you retrain this model, right? That's not just a simple application of that model. So I think this kind of, and this is really important for India. For example, even if you take an algorithm that can detect skin cancer, it'll not work well on Indian skin, right? Because it hasn't been trained on that. And so understanding these kind of basic problems, and also I feel we should warn this workplace against using AI in superficial ways. Like I think about this company called HireVue, which just takes a video and analyzes the face structures and gets a whole bunch of features and then suddenly gives you your employability. Now, I feel this is a very superficial use of AI, and therefore we must educate this, not only just the mechanics. They have to they have to have a deeper understanding of what it means about training, because these are not deterministic algorithms. These are stochastic algorithms, right? And they totally depend on what they've been trained on. And it seems like if you've got millions of images, everything is sorted, but clearly not, right? So I think we have to be able to do that. And also the other very, very, so I was talking to somebody on what type of skill sets. So they are the people who actually, produce the cutting edge machine learning algorithms. They may be the researchers and the people that you have in the lab. There are people who use those cutting edge in cutting edge applications. But there's even a level of talent that requires you to buy a machine learning algorithm for your organization. Even that requires a skill which is more than just looking at the specs of a machine learning algorithm. For example, how do you know machine learning algorithm is really doing what it's doing, right? Like, I mean, you can't specify it to standards other than some very superficial things like precision and recall and things like that, right? There's a lot more that underlies and underlays that area. So I think that it's a long answer, but what I'm trying to say is that the skills that we need for a judicious application of AI in society are quite deep. It's not just the mechanics we have to teach. We have to teach them about how this can impact society, how this can, it could be anything, but it has to be something that the society wants and takes and uses in a judicious way. So I think a holistic approach is required to these skills. It's not just going to be, I can do and I think it's a really good start to do the initial bit where you know the mechanics of it, but it's a journey that one has to learn. And to be honest, I haven't solved the problem myself as to how we get our students to do all this, because I find that even people who've got a PhD, when they come as postdocs, they will make the most simple mistakes, which have drastic consequences. And so even such a highly trained, because machine learning is like that. And so it's not, I just want to say that it's not a very easily learnable technology other than in the most simple sense. So yeah, maybe I'll stop at that point. And maybe that's not a very optimistic view, but I think that's the nature of machine learning.
Thank you very much. I'll come back to you. I think later on we'll deliberate a little bit on how do we build that skill set, right? So
yeah.
We'll come back. Come back. Thank you so much for your inputs there. I'll move over to Srijit. Srijit, you have a ringside view on this war for talent, right? In a slightly different perspective. Tell us about what you are seeing. And what do you think makes a successful AI professional in terms of you're involved in training data science and AI, students, AI, people who come for your programs, etc. So tell me what you're seeing and what are your thoughts on this?
Okay, thanks, Vijay. I would like to extend from the premises where Professor Venkatesh has left it. I fully agree with her points made, especially according to me, the most important skill set that an AI professional needs to have is creativity and business problem framing. The issue starts there. And as Professor Venkatesh mentioned, we need to solve the right problems. We need to attack the right opportunities. We need to understand where we can, let's say, result in the maximum customer experience, or where we can contribute maximum to the society or to the business profits, whichever problems we are solving. Identifying that problems, converting it mathematically, framing a problem set based on that, that's the most important skill set an AI professional needs to have. The second and equally important is the mechanics part. Now, the mechanics part is a combination of multiple disciplines. Now, AI or any of the related disciplines, this is an interdisciplinary field. It's not a pure science like a physics or a biology. It's like an interdisciplinary field. Most important being mathematics and statistics. That drives many of these modeling behaviors that we see. Ultimately, any AI algorithm that you take, it's a relationship between multiple variables. It's a relationship between a buying behavior versus a set of factors that influence it. It's a behavior versus an image and tag to which that image is attached to. Implications of that could be self-driving cars or scanning or whichever use cases we speak about. So ultimately, mathematics and statistics gives that engine which will lead to that identification of the right patterns. In mechanics is a programming skills. Now, programming is important, and that's because as the computing power grows, and now that we are also awaiting the launch of 5G very soon, we will have enormous computing power, and enormous amount of data is anyway already being created through social media and through factories and through everyday use cases and all of that. Now that combined with the computing power that 5G is promising, which is like multifold of what we are currently used to in 4G, programming can really create wonders there, especially with the application of machine learning and deep learning algorithms. We would be able to create very useful models which can solve several of the problems that the industry is having currently. So, so combined with statistics, mathematics, programming, and in programming, modeling is a very important part, in both machine learning and deep learning. I believe these are the few skill sets that will be extremely important. On top of it, creativity and problem solving will act as an ice factor.
Thank you, Srijit. If I were to summarize what all of you said, I think the demand is there's a huge demand. There's a huge demand supply gap, but then the skill sets is not very straightforward. Skill sets required to is not that straightforward. It is not just mechanical. It is not that you learn a language and you can do it, right? It's much deeper. It is much more understand the problem. You have to frame the right question, make sure that you're attacking the right problem. So let me just go into this a little bit more. Is that from what you've seen, what kind of strategies are people actually using to bridge the gap? And related, of course, when you're bridging the gap, then what are you doing to train train people, right? So any one of you, I mean, you could respond to this. Ashok,
Ashok, you're on mute.
Yeah, you're
sorry.
on mute. Yeah, sure.
Okay, so let me take a shot at it, and then obviously Professor Venkatesh and Srijit can add to it. I think all the points discussed were extremely important, right? So it is not just about technology; it is about a lot of maths, a lot of science, a lot of statistics, modeling. It is about actually framing, asking the right questions, etc. But what's also important is to actually see the various horizons in which AI is, right? So, you have conventional AI, which is basically about augmenting intelligence, right? So this will help you around prediction, recommendations, say classification, regressions, rules-based things and stuff like that. So if you look at then the horizon 2, which is around deep learning, right? So which actually is amongst other things, primarily focuses around higher accuracy and predictability. The deep learning systems, will drive higher order generalization. So the accuracy and learning capabilities, for example, the neural machine translations and conversational insights realized will be using deep learning algorithms. So what does this do? So this is basically around object, detection, speech recognition, facial recognition, speech transcriptions, generation, etc. So, I mean, we can actually consider that to be kind of a horizon 2, which is the deep learning part of it. But then when you actually look into the horizon 3, which actually, will need enterprises to work across, multiple AI subdomains, it is about responsible, transparent, generative AI. It is about explainability. It is about like a digital brain, if you like. And these systems will deliver intelligence, right? So with distributed learning through well-managed and governed AI systems. So when you look at, when you consider that, what would be the key patterns? This is about video insights. I think as Professor Venkatesh was saying, I mean, it is not about actually, coming up with sentient analysis, but just by looking at a video. I mean, yes, it does that, but is that really what's actually required, right? So the generative networks, and it doesn't need to apply to, as I said, only the key technical parts of it. It can be in music, it could be in video generation. And Srijit spoke about 5G. So how does AI actually work on the edge around mobile net? What about AI governance, the ethics aspects of it, etc.? So when we talk about AI, I think we need to actually think about it as in multiple horizons, because the applicability of that in different contexts is very different. So gearing up to deliver that, I think, is important. So when we talk about supply, it's a lot more than, as Professor Venkatesh was saying about, Python or R or Java or TensorFlow or NumPy or things like that. It's about how do we use it, the context of it, when will we use it. I think that's extremely important.
Yeah, so maybe I can kind of jump in there, and I completely agree that I think it's in these several horizons, and I think what we have currently solved is what I call just pattern recognition through machine learning, where we have learned how to learn patterns. So I think the AI is a much more complex goal that we have of where we can do many more complex things like planning and complex intellectual tasks. But right now, all we've done is we've constructed these machines that can take data and somehow extract features from them magically through these deep networks, and then do, if you actually look at the prediction is very, very simple, right? So it's the feature extraction that we have done really, really well. And I think you're absolutely right. I think that right now we should go for training people who at least know how to do that, and then move towards the AI. But I feel there's just not enough people to go around. So I feel that the way we should tackle this problem is a little bit different from previous years, where universities would just turn out people and then send them to industry, and then they would work in these little silos. A number of people in Australia have been asking me this as well. And now we're setting up these kind of partnerships, like, if you like, collaborative labs or collaborative places where students and industry can work together. Because there's just not enough people to go around. If you say that you want 1,000 people in Australia, you don't have 1,000 people in Australia. You can't train them fast enough. So how do we make the best use of existing resources? One way to do that might be to share them, at least in the short term, construct these collaborative frameworks between industry and universities and other people who train such people, and then go from there. So that's a kind of a model, I think, that I'm working towards, because it seems like something we can do in the short term, given the constraints we have of the number of people who are at that skill level.
Switha, sorry, Vijay, I'm going to come in here, and I'm going to sort of ask a question. Switha and Ashok, from your perspective, when there is such a important need for this talent growth to come up for the industry, for business outcomes, and for providing a ready base for companies to take to deliver what they need to, how can industry and academia come together to close this gap? Because I've got like three very senior people here. You, Switha, being sort of at the university, and Deakin being an innovative university in providing solutions to industry. Ashok, you being in industry, and Srijit and Vijay being in KPMG consulting with industry. I think it's a great sort of discussion to have as to how we can all come together to provide a solution that can take care of the foreseen future to provide talent.
Well, I can give you my experience, and my experience is that we are starting to set up these things called collabs. They're like collaborative labs, and they're very different from previous research partnerships we have with industry, where they'll give you like a task and you go by contract and you deliver the result to the task. These are more collaborative arrangements where you're willing to try a problem. They bring some people, we bring some people, we solve a problem in common. We can fail, but we hope that we don't fail, and we try and advance the field. So this is what I mean by this kind of collaboration. So we've set up, for example, a collab with defense. We're in the process of setting up another one with another industry partner. So I think that seems to be one model, that's a sharing model, if you like, that I'm experimenting with.
Yeah. Thanks, Professor Venkatesh. I think industry uses slightly different nomenclature, right? So we call this as the living labs within Infosys, because we believe continuous learning is a given, right? Gone are the days where degrees were crafted. You do your 4-year thing and you come out. Today, if you spend 4 years, you pretty much already outdated when it actually comes to technology. So I guess, the mantra is not actually, look for a job. It's actually even looking actually beyond skill. I mean, I think it is actually looking about the mindset. It is about learnability. Being very cheesy about it, it's not the skill, it's the will of the person whom we need at this point in time. So Living Labs, we basically have probably, you touched upon the two key, constituents within the ecosystem, which is one is the academia and the other one is the industry. And Living Labs, I think, probably you do this in collabs as well, to also actually bring in the government, because government plays an extremely important role, in terms of its policies, in terms of investments, both into the academia as well as into the industry, so that you can actually do and invest a lot more in research. So the Living Labs works because, see, the industry has got a very breadth view, maybe level 3 depth on each of these subjects, but unless we partner with academia who have got deep research knowledge, and then actually not, come up with use cases just because we want to prove technology. The proof of concept and proof of technology are days which are gone. I think we are in an environment where we are actually creating sandpits. We want to actually create minimum viable products out there in the market, or actually solve a problem that is there in the community or in the industry. So bringing these problems through our clients into the Living Labs and partnering with academia who have the deep research knowledge, I think is what we are actually seeing that is actually paying dividend today.
Just want to add one
Anything,
very quick point to it. In fact, connecting both these views, what we have seen is increasingly happening is that the use cases that are required in the industry for many of these AI problems are changing at a very, very higher pace, and which brings in the importance of that continuous learning that Ashok spoke about. And the modes of learning is also very, very different and drastic now. From a typical classroom type learning to videos and hands-on activities and audiobooks, and in fact the possibilities are immense. And in fact, thanks to the pandemic situation that we are in, people are again actually very comfortable to use these digital modes of training as well. So connecting that back to the rate at which the use cases are also growing, academia has got a very, very important role to play by helping in the research and development process to address some of these newer problems. We've got the kind of libraries that we see creating, that are generating in Python and R every single day. There's of course a collaborative effort between the latest trends in the industry, combined with theoretical knowledge, the research input that are published in several of the premium journals. So I think that's one area where both these entities can definitely join hands.
Thank you, Srijit. I just had a question. Sorry, I got I got moved out of the webinar because of a network issue. But just have a question. I don't know if that's been addressed before. Given that there's a huge gap and there's so much of demand for talent, are you seeing organizations trying to reskill people from their other functions into AI professionals? Like Professor Venkatesh mentioned earlier, is that it's not just the tools, it's a much more deeper understanding of the problem at hand. And one would assume typically is that if, let's say, I'm a supply chain professional, never been in, let's say, done anything in computer science or anything, can I become an AI professional, right? Is there something, what are your views on this?
Actually, in some of our collabs, I think, for example, we do these workshops, which are hands-on workshop of a very targeted thing. It's not at the very basic level, but it's at the level of they already know some amount of machine learning, and then we're working on an advanced topic together. So that way we can kind of transfer skills that are much more complex sort of area to them. So there's several levels of training. There's like basic, intermediate, advanced. And I think you can have these kind of co-training sessions where you can impart knowledge in a very targeted, 2-3 days. And yes, we are seeing organizations doing that now.
Sure. Ashok, thank you so much, Professor Venkatesh. Ashok, your views?
Yep. Definitely, Vijay. I think as Professor Venkatesh mentioned, and I think Srijit kind of actually touched upon that as well. I mean, if you really look at the talent pool today, which is out there, right? So one is about, of course, the graduates who would actually coming out of the university. Obviously, they have limited experience. So the learning curve for the graduates is more about what are the practical applications, how the industry actually looks at it, and the context rather than actually just the technology in itself. But that it is fantastic because I think there is an eagerness to learn for them, and it's much easier to actually do that. But when we actually look at the gap between demand and supply, right? So I mean, we don't have a choice other than using technology to free up resources who have the ability to learn adjacent technologies and basically reskill them up and upskill them in AI, deep learning, or any other new technology, blockchain and others, and that is extremely important for us to do. But where I think also there is value is, I mean, I think, pandemic, of course, is a very regrettable event, but every cloud has a silver lining. All those who have actually been impacted by the pandemic, either through past projects or basically have lost jobs, I think a career transformation, a transition of career also is applicable. See, for example, I mean, I think Srijit pointed this out, right? So earlier, statistics, maths, data science is all extremely important. Just doing analytics in a university will not make you a data scientist. I mean, for you to be able to actually connect the dots, you need the experience in the industry. So today, by virtue of the displaced people within the industry who have this knowledge, I think you can actually bring in the data scientists with minimal training to basically help connect these dots in specific industries. So all of these, I think, will have to fill the big gap that we have between demand and supply, especially around AI and machine learning. And of course, deep learning is a completely different thing. I mean, I think as Professor Venkatesh was saying, it is in a very nascent state even today, even for a large company. So I don't believe we have a choice other than reskilling and upskilling resources to that.
Sure. Thank you. I have one last question before we move into the questions that the audience has sent us. I know, just kind of looking at the time. What's your view about this war for talent? Is it going to intensify, or is it going to reach some kind of a semblance of where demand is meeting supply?
I mean, I can go, I guess, in one word. I think the war for talent will only intensify. And when you actually, look into the substrata of it, right? So when you start peeling the onion into saying, okay, because AI is very vast, right? So machine learning, there's MI, deep learning, visualization skills, there's programming language, there's data integration aspects of it. The big data, cloud native actually comes into it just to actually give you the scale for compute storage, as I think you were mentioning before. Applied mathematics. So I think war for talent, I think, will intensify, not just amongst organizations. I think across the countries, I think we'll see the war for talent. But the good news is that the pandemic, normally for any organization or even at a country level to actually get through a change management exercise is a decade, right? So whereas pandemic has actually forced a lot of us to actually think very swiftly, and we've seen amazing transformations which has happened in 6 weeks to 3 months, and so the countries are actually doing a lot, which means that as we have seen, and a lot of this has actually been written and spoken about, which is around workplace and workforce transformation, which is happening, and being able to actually get talent in the right talent in the right place, the remote working aspects of it, I think will help in this war for talent. But I think the gap today, where we see the demand where it is, I think the war for talent will continue for a period of time.
Thank you. Srijit, would you like to
answer? Yes, Vijay. Short answer, absolutely yes. And I'll also tell you the reason. And there are several sub solutions which will emerge from AI, which we are not even aware of currently. A few of the things that we can even think of is, for example, ethics in AI. The unknown biases that AI is creating, how to tackle that. Auditing in AI, is information security, and also all these related areas. For example, today there might be people who are working in radiology departments, and tomorrow there could be AI designers of radiology. Likewise, drone pilots. We don't know. There could be job titles that we are not even aware of currently, and it's very hard for us to contemplate now on what that could be. So these are the few possible streams that the AI will throw up, not just on the direct stream, but also several sub-solutions of what AI can possibly do.
Sure. Thank you, Srijit. Any last comments, Professor Venkatesh?
No, I think it's been covered. Yeah.
Okay. All right. So we'll just go into the questions, and one of the questions that is coming up, and I think I'm just looking through the questions and seeing the theme. As a computer professional who has not been a part of any AI projects, what should be the focus? What should be the way in which one should upskill themselves? One is it's fine to understand the applications in AI, but what can be done in the short term? So anyone, whoever wants to pick this up. Ashok, would you like to respond?
Sure. I think from an industry perspective, we'd like to see more of what I guess Deakin and KPMG has done. I mean, that is exactly the point. I mean, it is about not just the academic knowledge. It is about actually translating that into experiential knowledge, translating that into, I think Srijit mentioned about identifying use cases which will actually solve common problems. Doing hands-on projects, I think, is extremely important, rather than actually just writing exams and passing exams, which to an extent is needed for the basic foundation of that, but applicability, the application of it, I think, is extremely important. And when we talk about AI, applied AI, is a stream that is is becoming extremely important now. I'll just stop there.
Sure, thank you. And just another question. AI promises to offer entirely new business models and economic value. Industry seems to look at this as a technology-driven solution. Academia is bridging the gap from old to new skills. We need to unlearn what we know to understand and apply AI. Professor Venkatesh, would you like to?
Sorry, I couldn't get the question. So what is the question?
So the question is, do we need to unlearn what we know in order to understand and apply AI?
No. It builds on maths, it builds on statistics, it builds on knowledge it builds on programming skills, and so no, that's not. You just need to learn a lot more, but don't have to unlearn anything.
Right. Thank you. There's another very interesting question that has come up. AI is impacting finance and treasury functions, right? So how can chartered accountants upskill themselves? Srijit, do you want to take a shot at it?
I've seen several chartered accountants in KPMG who are actually excellent, I would say consultants in AI, who are advising banks, who are advising GCCs, who are implementing artificial intelligence and robotic process automation in several of the financial institutions that we speak. And that's where I would like to connect to my previous point. So some of these, things. I think I was also reading to a question: isn't domain knowledge important? Domain knowledge is absolutely critical to make this work. I think Ashok was mentioning about it. A university grad who is a fresher will have the curiosity to learn the industry application and all of that. But imagine someone who is actually in the industry, say for 5 years, for 8 years, for 10 years, he or she knows the way in which business works. Combine that with the power of what AI can do. That's where the real magic happens, where we are actually able to solve the problems for the organization and also for the customer. So direct answer to that, absolutely CAs can add a lot of value to the way in which many of the problems in financial services are formulated.
Thank you, Srijit. There's also a very interesting question that has come in. Several questions that have come. Is that when is that day? I'm just summarizing the question, but when is that day when robots or artificial intelligence machine will rule humans, right? So it's a far into the future kind of question, but Professor Venkatesh, your thoughts on that?
So I think that the answer there is that these kind of artificial intelligence will become embedded, much like we have electricity today. And the thing is, you won't even know in what way it's controlling you, right? And so it's not the Isaac Asimov, robots that will be roaming our streets, or that could happen too. But I think that they will control it. Like, for example, everyone knows about the Facebook, the way it influences people and addicts people, and it's algorithmic. It's algorithmic, right? There's no human doing it. The reinforcement learning has been given a reward that does that particular function. So I think that is a danger that I'm quite worried about, in the sense that one should have a population that can understand in what ways the embedded AI is influencing them. Like, I don't know whether many people would know how the Facebook algorithm works, right? And they think they're in full control of what's happening. Actually, they're not, right? So those kind of things, yeah. So I'll keep it short.
Thank you. I know we are really out of time. I'll just take up one last question, and that is, and it's again, I've seen multiple questions come in that in that direction. Is that, what is the roadmap if I am an individual not from the computer science background? What is the roadmap for me to get into the AI field? Ashok, do you want to? Oh, okay, Srijit, go ahead.
Go ahead, Srijit.
Yeah, I'll just make it quick, and Ashok, it's a question you're used to. My suggestion from my own experience is start leveraging your own existing strengths, whether it is mathematics, whether it is statistics, whether it is domain knowledge, whichever industry you come from, whatever background you have in the degree, start that as make that as a starting point. Combine with that and add additional layers to it on whatever other skill sets that we were speaking about in AI currently. That includes programming, that includes formulating the problem, it includes understanding of the domain, deep learning, etc. Understand a lot of case studies and applications on how AI is helping currently, what AI can take us to a future point in time. So these would be the initial few steps to make a very, very quick point. Over to you, Ashok.
No, I think you have made a very comprehensive point there, Srijit. So yeah.
Okay. Thank you so much. Thank you, my fellow panelists. It has been actually a very, very interesting discussion. I wish we had more time. There are so many things we wanted to discuss. I personally had a lot of questions on it, but that's for another time maybe. And I'd really like to thank Ravneet and the entire Deakin team for organizing this this discussion, and to all the participants for taking out time on a Saturday morning to come and attend this webinar. Thank you so much.
Thank you to my colleagues from Melbourne, Switha and Ashok. Thank you for giving up your Saturday, well, almost evening, I would say. To Srijit and Vijay, thank you from KPMG. To my colleagues and all the participants, thank you very much on behalf of Deakin University. Thank you.
Thank you.
Thank you so much.
Thank you.